Vibrations can indeed cause significant damage to HVAC components over time, leading to premature wear and tear, reduced efficiency, and even potential safety hazards. Several factors contribute to HVAC vibration problems. 1. Oversized equipment. When HVAC equipment is oversized for the building's needs, it operates at lower efficiency, resulting in more frequent starts and stops. This constant cycling generates excessive vibration that can stress components and shorten their lifespan. 2. Inadequate support. Improper or insufficient mounting of HVAC equipment can allow it to vibrate uncontrollably, transferring these vibrations to surrounding structures and causing noise. Proper vibration isolation mounting systems, such as resilient mounts or vibration dampers, can effectively minimize vibrations. 3. Imbalance of moving components. Imbalance in rotating components like fan blades, flywheels, or compressor rotors can cause excessive vibrations, leading to premature wear, noise, and potential damage to other components. Regular balancing of rotating parts is crucial for maintaining system stability. 4. Airflow turbulence. Uneven or excessive air velocities in ductwork can generate turbulence and resonance, resulting in noise and vibration. Proper duct design, smooth transitions, and appropriate dampers can help reduce turbulence and minimize vibration. 5. Loose connections. Unsecured connections between duct sections, piping, or equipment can allow vibrations to transmit throughout the system, causing noise and potential damage. Regular inspections and tightening of connections are essential for maintaining a stable HVAC system. To address vibration problems and prevent damage to HVAC components, consider these strategies. 1. Proper equipment selection. When selecting HVAC equipment, ensure it is the appropriate size for the building's needs to avoid excessive vibration due to cycling. 2. Vibration isolation mounting. Use resilient mounts or vibration dampers to isolate HVAC equipment from surrounding structures, preventing vibrations from transferring and causing noise and damage. 3. Regular balancing. Schedule regular balancing of rotating components like fan blades, flywheels, and compressor rotors to maintain optimal balance and minimize vibration-related issues. 4. Duct design and maintenance. Employ proper duct design practices to minimize air turbulence and resonance, reducing noise and vibration. Regularly inspect and tighten duct connections to prevent vibrations from propagating. 5. Annual inspections and maintenance. Conduct annual inspections of the HVAC system to identify any potential vibration issues, loose connections, or imbalances. Promptly address any concerns to prevent premature component failure and maintain system performance. Thanks for listening. Check description for much more.